Hello everyone and welcome back to another episode of the Hidden Quantum Champions. Today we are looking into a company called Artificial Brain, and we are going to learn how they actually help different sectors within the field of, data to get quantum ready, to use quantum for specific applications. And if that's interesting to you, if you are, let's say, potentially one of the people that, to apply quantum to your algorithmic workloads, then today's episode is the right one for you, so stay tuned as we are diving deep into Artificial Brain. And here we are, as per usual, on their website. So you can see this nice animation in the background, and it says Democratizing Quantum for Industries. From aerospace to pharma, Artificial Brain makes quantum computing accessible across industries. Type it, solve it, deploy it. And the way that they are doing it is through their Planck platform. So the engine behind Democratizing Quantum for Industries is the Planck platform, right? What are the benefits of using that? So it says cost savings here, reduce cost by 30 to 40% compared to traditional methods. Speed, so from days to minutes, 1+ million variables solved with speed and precision. Natural language to quantum solutions, and I think that's what makes them also very interesting and very unique so far. Empowering users to access quantum without complexity. So I assume there's some, let's say, language level input, like an agentic AI, and then in the background it builds the code based on what you're telling it to do, and then domain agnostic, so from mission critical defense to life-saving pharma. So why Artificial Brain? No training required, high bandwidth optimization, quantum plus AI expertise, and then global presence, so footprint in the US, Europe, and India. They are specialized in quantum and AI, processing of massive data sets, and then extensive training. No extensive training required. Okay, then we see here some research highlights that they are putting here. So this is quantum AI hyperspectral intelligence enabling unmatched speed for critical decisions, Planck energy optimizer, quantum intelligence for predictive, efficient, and real-time energy management, and optimizing air defense systems, so using Artificial Brain's Planck quantum software. Here we see the team. In that case, the CEO, Chief Strategic Advisor, and Chief Customer Success Officer, as well as the latest updates. I'm recording this video in May of 2026. The last update that we see here is from September 2025, so it's not, let's say, fully up to date. And down here we have, as per usual, a way to get in touch with them, as well as the typical contact details. It's artificialbrain.us, so I assume we are talking about a US company here. But let's quickly check out the products. So I guess the product is the Planck platform that we saw before. So it says Planck Quantum AI Platform, Democratizing Quantum Computing for Industries. And we see here different, use cases or case studies. Energy, so enter natural language problem description, and that's where it starts, right? So consider, as an example, consider N energy sources, for example, fossil fuel plants, wind farms, solar farms, and batteries. 2 wind farms, 3 solar farms. Each source has specified capacity and operating cost. The total demand is 2,500 units. Optimize the selection of sources to meet the demand at the lowest total operating cost. And then you see here that it basically generates this output. I guess there's also some algorithmic output, which then generates this donut chart here, where we see the different energy sources and the total cost in dollars, whatever that actually means, right? It's the operating cost, but yeah, okay. There's also some trajectory optimization problem here, which they highlight as a showcase, and some pharma-related pick as well. Okay, besides that, we see again the points that were pointed out already before. Explore different domains, so you can actually, deep dive into some of these products built on Planck platform. So here now we see some use cases or different industries for use cases. So aerospace, energy we saw before, right? Defense is mentioned, agriculture, pharma we saw before, and IP legal. Let's quickly just check out IP legal as an example. The other ones are here written down as well. So Planck AI patent assistant automates patent drafting and analysis, patent draft automation, prior art search, and then legal compliance checks. And you can also, via this button, request a demo from them. And the same is true for all the other cases here. So we see multiple different application cases listed in here. And I guess like looking at them, it's also not surprising to see that, okay, there's some aviation optimization here. We've seen that before, right? Energy demand and I guess also grid optimization types of applications. In the pharma, we have some I guess molecule related topics, right? Rapidly transforms unstructured health data into organized, accurate data sets, saving hours of manual work. Well, that's maybe more on the data set side of things, and enabling early detection of adverse events. So that's also, let's say, not the super typical stuff that we are seeing, but optimization problems in there as well. There's a research tab here as well, linking to all the research that the company has been associated with. So exploring the frontiers of quantum computing and artificial intelligence through cutting-edge research, and then quantum computing for flight, takeoff and landing optimization towards an optimal hybrid algorithm for EV charging stations, placement using quantum annealing and genetic algorithms. So this is, let's say, an optimization algorithm or an optimization problem as well, right? So you have a national grid of streets, similar to a national grid of electricity. Now you're looking at the streets. You have electric cars, right? They have a limited reach because of the battery. And I mean, the same is true for gas cars, but the problem has been solved many years ago by finding the right spots for the gas stations. Now for the electric cars, those stations might be in different locations. And now the trick is to figure out, okay, how frequented are certain streets? What is the typical energy consumption associated with it? So on a highway, an electric car will eat more energy than maybe on a street where it can only drive much slower because of the wind resistance, right? So you might want to have, let's say, closer distances on the highway, and also the highways are much more frequented. So it might make sense to have more, let's say, overall charging stations on a highway than maybe on some place that is a little bit more remote, but still you need to put some in the remote location. So it's an optimization problem. You need some data, as in like frequency of cars going through the road, and you need also to know the distance of that a typical electric car is reaching with a battery load. You might not want to go from 100 to 0, but maybe something from 20 to 80%, so only 60% of the battery load. All this information goes in, and then you can run this optimization problem, just as one example, right? There's more here. So quantum text teleportation protocol to secure text transfer using quantum teleportation and Huffman coding, then quantum image transport teleportation protocol and quantum audio teleportation protocol by using quantum teleportation and Huffman coding. Space sustainability using quantum computing for Mars exploration, opportunities and challenges, quantum powered energy mix optimization for cost-efficient energy demand management and meeting renewable targets, and then quantum computing for sustainable energy optimization, wind farm layout for improved energy efficiency. So these are, let's say, I think the energy grid kind of examples are more the typical ones. Mars exploration is something that I have not seen yet so much in the context of quantum computing. But maybe let's quickly check this one out as an example, just to see what this paper is about, right? So we see quantum computing has garnered significant attention in recent years for its potential to revolutionize a wide range of fields, including space exploration. In this paper, the authors investigate the potential for quantum computing to revolutionize future Mars missions. Quantum computing offers a number of advantages over classical computing, particularly in the areas of optimization and simulation, which could be leveraged to improve missions a mission planning and resource allocation model and predict the Martian environment, and develop new materials and manufacturing techniques. The authors provide a detailed analysis of these and other opportunities presented by quantum computing in the context of Mars exploration and colonialization, highlighting the potential of this technology to significantly enhance the success of future missions. However, the authors also recognize that quantum computing presents several challenges for space exploration and discuss some of these challenges in the paper. Ultimately, the authors believe that quantum computing has the potential to significantly enhance the success of future Mars missions, but it will require careful planning and consideration to overcome its unique challenges. And I mean, that sounds almost already like a sci-fi story. So I guess it's like thinking ahead quite a bit, because I guess we are not yet at the point where we can talk a lot about Mars colonialization, because we only have sent a couple of, I think, like a rover there, some satellites there, but there's not, let's say, like for example with the moon, any mission that like humans have been even, let's say, considering of going there, right? So I guess it will take still a little bit of time. I mean, Elon Musk is getting ready with SpaceX to actually send robots, I guess, to Mars. So maybe we are closer than we might think. But yeah, I think this is like very forward thinking, then also including quantum computing into this whole story. So Mars exploration itself is already a future topic. Quantum computing is, I think, like useful quantum computing is still a future topic, and now combining those is even further more ahead in the future. And maybe one thing that's interesting to note in this context, and you can search also after watching this video, of course, there is some research from MIT, I think it was, looking at quantum computers and space particles. So as you probably know, our sun is emitting a lot of fundamental particles, elementary particles around itself into all different directions, and also of course in the direction of planet Earth. So we are being penetrated by those space particles constantly, permanently. Think about particles like muons, which are very, very fast, and they are entering the Earth atmosphere. They are going through, and sometimes they're interacting, sometimes they're not interacting with the Earth matter. And this is happening on a constant basis. So if you think about a quantum computer, which is basically operating on quantum levels, on quantum energy levels, if such a muon would hit the chip, then it could excite one of these qubits into a different state and hence destroy, let's say, the overall superposition and entanglement state that you might create across your chip. And actually, there has been some research by MIT where they put I think it was MIT. They put a quantum computer somewhere in the basement, and then they had some, I think, lead shielding, which they applied to kind of shield even better the radiation sources. And then maybe they also had a radioactive source, which they put close to the chip. And you could really see in the data that not only the error rate was going up, but you could even, I think they could even observe that like when the particle hits, you could see that basically one qubit is flipping, and then around this qubit the error was kind of spreading outwards. So you could really see that like in a wave pattern, this quantum error is actually then spreading from this local source across the whole chip. Go ahead, check it out on the internet. I will probably not be able to link it down below the video, but if that's interesting to you, definitely something to check out. Now, as per usual, let's also quickly check out the team behind Artificial Brain. So I think we saw it already before. So we have here the executive leadership team, but there's also a development team, which you can see here. There's some advisors included as well as consultants. Some of the highlights, so 10 plus team members, 150 years plus experience combined, of course, across quantum computing and industry applications, and also combined across the whole team, right? There's no person in there that is more than 150 years old. And then 10 papers and patents that are associated with the company itself. Let's see if we can also see something else here. Okay, so you see there are different offices across different places. So in the US, you have an office in New York. Then there's a European office based in the Netherlands, in Delft. And there's an India office, which is in Pune, I guess. Not sure. Which represents the company within India. Okay, but with that, I think we are already at the end of today's video. That was everything that I wanted to share with you about artificial brain. I hope you found it interesting. If so, please make sure to subscribe to the channel. As always, make sure to stay hydrated, and then looking forward to see you back in the next video. Until then, bye-bye.